Welcome back to the channel, and today's going to be a few things. First, we're going to build I'll show you. I'm going to build a spindle block for my new mill. It is a 40 by 40 millimeter by 20 millimeter deep part. Use some M5 clearance screws countersunk and an M6 screw countersunk. You can use the original and just jam it in there if you make the hole bigger, but we'll see how it goes when I build it. Also today, I want to do a little channel update. Unfortunately, the second part of the build of the mill didn't go so good, so I gotta wait to save some money up to get some more aluminum for that. So, what is his name? So, David Hudson, I didn't forget you. I will probably start the redesign part of the new mill next week, or next video rather. Not necessarily next week. But I realized there's some flaws in my design that I had to work out, and well, that's how things go sometimes. Let me get to the build and I will get back with you when it's done. Okay, as you can see, I had to do a little slot milling. I didn't show that on video because I don't have a proper collet for it yet. So let me snip this out of here. So I used the drill truck, which is totally not recommended. Don't ever do that. This thing can break loose, fly off, and cause serious injury. So I didn't want to video that. My TTS collets will be arriving. Honestly, they'll probably be here by the time you see this video, but I was kind of impatient. So I had to do a little slotting here because I mismeasured when I made my drawing. It should actually be a 5mm top shelf, not a 10mm. But I will rectify that on the drawings when I stick them up on the website. I also opted to just reuse the old spindle lock key. You just kind of wiggle it in place, it stays in place. I am going to drill a hole through this and put a red flag on this just so that it's obviously in my face. Hey, don't be an idiot and start the mill with this installed, because bad things could happen. That being said, this is a belt driven mill, So I think the most that might happen is the belt might slip. I don't want to risk that because I like this little machine. And that brings me to the machine. I decided that to finish that other project, I really need something that was a lot more rigid than that little crappy Harbor Freight tool drill press I had. And hand drills, it just... And I tried using a hand router to mill out some pockets, and that didn't work out very well either. Matter of fact, that went really bad, to the point where it wrecked the part, and that's why you're not seeing that video. So, as far as this goes, it's a little machine shop HiTorque 3990. As you can see, I don't have any DRO or anything on this. And that's why you saw me scribing everything and just going to the scribe lines, because these hand wheels are terrible. They're in 60 thou increments, and I don't really work in 16th inch math. So at some point I've looked into it, and the cost to get a DRO for this is actually the same cost as it is to get the CNC kit for this. So I'm probably just going to CNC this and then have 2 CNC machines once I get the other one done. I can use this one for steel because it actually has a slow spindle speed. You can, here, let's see, you can get this down to like 50 RPM, all the way up to 2500 RPM, which is the perfect range for steel. Whereas the CNC spindles that you see me use, those don't do steel well. They spin too fast, and they're more for aluminum. So what I'm going to probably end up having is a steel dedicated machine and an aluminum dedicated machine. And this one, just the weight alone is a lot heavier. I put a 67-pound plate on there I bought from a metal supermarket, and I just drilled and tapped some holes to mount it to this plate, and that's just sitting on my Craftsman workbench or toolbox. It's a little wobbly when I run it by hand, just because you got a lot of mass on the arm going there. But I suspect with the stepper motors, it'll be a lot smoother, just because you don't have that jerking force that you get right now. And worst case, I can always move this plate onto a workbench if it comes down to it, but I don't think I'll need to. Let's see, what else with this? So what that does mean for the channel is there's going to be a lot more manual machining in our future until I either make the conversion kit myself on the mill, or just buy it and convert it. But to be honest, it's been pretty fun just using it as a manual mill for now. And for the other project, it's actually preferable for this to be manual mill, because I don't have to keep programming all kinds of setups in Fusion to make the different slots and holes. Whereas here I can just put the part where I want it on the table, clamp it in, drill the hole, do the part I need in that spot, and then move on to the next setup. So I'm probably going to keep this manual at least until, here, let me move the camera a little bit here so you're not looking at my beard. So what I'm probably going to end up doing is keeping this manual at least until that other CNC project is finished, and then I'm going to probably CNC this thing. It's already got all the equipment from my old mill already here, so it is zero effort for me. Really, all I have to do is put the ball screws in, change out the mounts, and then just plug everything back in and ready to go. Also, on that last depth of cut pass I did on the part here, I actually managed a 95 thou depth of cut on a 4-flute facing mill. I think this is it. So I was pretty impressed by that. This little guy went down 95 thou. Didn't even really have a problem. I did get burnt pretty good with a few chips, but as far as the machine goes, that was awesome. I've never been able to cut that much at once, and that was a full 10 millimeter, or actually in that case, that was a 20 millimeter width of cut on top of that. So I was slinging chips pretty good. My entire garage floor is just covered in them here. All kinds of mess, but as you can see, there's a lot of chips on this floor right now. Let's see what else is going on with the channel. Well, obviously, CNC is going to be a little less common for the near future. I still plan to provide drawings for all my projects, and that's not going to change. If I forget to do it, just leave it in the comments. So, whoops, I didn't have you facing me. There we go. If I don't do it, just leave it in the comments, and I will upload it and put a link in the description. One of my other projects I'm working on is, let's see if I can rotate this. I'm rebuilding my lathe. All the control panels, that kept burning out serial connection chips, so I gave up on it, and I am going to convert it to Pokey CNC just like I had on my other system. Luckily, it's already got a power supply in there that runs the stuff that's in there, so I'm not concerned about that. And I might be able to actually reuse the driver board that's on there. We'll see. And that would be nice if I could. That's really about it for the channel update. Whoops, sorry about that. Let's see if there's anything else I can think of. Nah, I think that's actually about it. If you have any questions, leave a comment. I enjoy answering them. If you have any project ideas you'd like to see me try to do, leave those also in the description. And as I get to know this machine, I will let you know how I feel about it. So far, I've made a few parts on it. It's obviously a lot faster if you have DRL, but I don't have that, so that's neither here nor there at this point. But as far as I can tell right now, this is actually a pretty good machine. And it was only $1,200 on Amazon, I think, when I bought this. And then I had a bunch of Amazon credits, so I only ended up paying like 200 bucks for this, so that was pretty nice. But they were pretty good to work with. It showed up a day late, but I think that was more of a FedEx problem than a little machine shop problem. But let's see here. Other than that, I don't think I have anything else. So I'll talk to you guys next time. Have a good day. Bye.